For many decades, mankind has been trying to find even the smallest sign suggesting the existence of an extraterrestrial civilization. We observe space around the clock using the most advanced telescopes. With bated breath, we listen to the barely perceptible rustles in pitch darkness. Space responds to us only with the soulless chirping of pulsars and the white noise of the cosmic microwave background radiation. But one day, on August 15th, 1977, we did get a signal. It was so powerful and like nothing else before that it was just wow. And this signal has been haunting scientists, space enthusiasts, and simply dreamers for half a century. The WOW signal. Full history and explanation. In 1977, the SETI, Search for Extraterrestrial Intelligence program, was in full swing. Humanity was still full of optimism and enthusiasm in trying to discover signs that extraterrestrial intelligent civilization exists. The SETI program is directly funded by NASA itself. The Big Ear radio telescope has been listening to space noise day after day for many consecutive months. Scientists and enthusiasts were scrupulously trying to find something unusual in the received data. For a long time, the space responded with almost nothing but silence. All of a sudden, the silence was briefly broken on August 15, 1977. Dr. Jerry Eyman registered what all enthusiasts have been looking forward to: a sharp, powerful radio signal from space that was fully consistent with the theorists' expectations of extraterrestrial contacts. It stood out so strongly against the background of the usual cosmic white noise that Dr. Eyman excitedly circled the encoded signal recording in red ink. He uttered this very exclamation, which immediately became the permanent name of the signal itself and the event in general. Until now, many seriously think that WOW is the deciphered meaning of the alien message. In fact, if Dr. Eyman had been a little less restrained in choosing his words, he could have written anything, even WTF, and then the signal would have been called the WTF signal. But don't let this little revelation disappoint you. The signal actually came from outer space, specifically from the Sagittarius constellation. There's no doubt about it. The audio that allegedly represents this very signal is widely shared on the internet. The fact that it went viral simply obliges us to play the recording. Are you ready? Let's hear it. We don't need to point out to you that fans of extraterrestrial civilizations, and especially skeptics, have broken the audio into pieces and analyzed every bit. Everyone wanted to confirm or deny its authenticity and extraterrestrial origin. And for the very first impressive results, neither a supercomputer, nor neural networks, nor symposium of experts were needed. It was enough just to speed up the recording. Get ready. This can sound frightening. What is this? Is it trying to communicate with us? Is this a greeting? Or maybe a threat? Did these sounds inspire Ridley Scott when he created the engineers' voices in Alien Covenant? Let's do the same thing that picky enthusiasts did a long time ago. Let's slow down the recording even more. Somehow, it doesn't sound scary at all. In fact, it's very earthly, isn't it? It's difficult to make out the voice, but it's possible. It says in English, "We lost him at 7 p.m. We've got a 1061. What is 1061? This isn't hard to figure out with basic Googling skills. It's simple. This is a police code that means stopping a suspicious car. Yes, pranksters or hype seekers just took a random recording of police negotiations and slowed it down several times. The usual simple fake. Well, it's either that or aliens from a distant planet also speak English. And even now, it doesn't disappoint us. After all, the signal itself is definitely not fake. Okay, then what does the signal actually sound like? After all, is there a real record? No. The Big Ear telescope didn't record any sounds at all. Its task in the study was only to record the signal strength. That is, this mumbo-jumbo circled by the scientist is all we have. But this doesn't negate the value of this data and the unique nature of the event. And now, we need to figure out what this unique phenomenon is. First, we need to understand what the Big Ear actually heard that day. Let's look again at that same historical document. All these numbers on paper are signal strength designations. As you can see, everywhere there are mostly numbers and small ones, ones, twos, or just blanks. And the WOW signals code looks like your Facebook password or something that a cat typed when walking on a keyboard. The fact is that the radio telescope encoded the signal strength into numbers from 1 to 9, and if the power was greater, it used an alphabetical series from A to Z. Remember we said that the radio telescope listened mostly to white noise? These are the very ones, twos, less often threes. Space is intensity less than 1. 6 or 7 was something out of the ordinary. That special attention was also paid to such bursts. Dr. Iman circled even them. And now imagine that against the background of these weak signals, which have already become familiar over the months of observation, the Big Ear suddenly registers this. There was barely enough alphabet here to display the strength of the received signal. It turned out to be 30 times more powerful than what the radio telescope had heard for a long time before. This was the first time such a thing had been registered. And now, to make it clear, it is worth noting what the Big Ear radio telescope was like at that time. In general, when it comes to radio telescopes, we imagine something like this: a huge, impressive antenna looking into space against the backdrop of a beautiful sky. And basically, radio telescopes are just that. But not only wasn't the Big Ear that aesthetic, but it lacked some of this functionality. Here's what it looked like. More like a football field, giving an impression of something unfinished. The question is, how did it turn to observe not one point of the starry sky, but other areas? The answer is simple. It didn't. It rotated along with the rotation of the Earth around its axis. That is, it could observe the same part of the sky only once a day for 72 seconds. That's why the signal is exactly 72 seconds long. And here too, the dynamics is clearly visible as you move. For the first 36 seconds, the signal grows louder, reaching an incredible peak, and fades out during the last 36 seconds. The way the signal was detected is by no means the same as in the film Contact. Dr. Iman didn't watch the equipment day and night. but noticed the surge only after it happened. But even if he registered the signal here and now, the next communication session would happen the next day. And so it all happened a day later, and then more than once, the research team tried to detect this signal again. Other radio telescope teams joined in this big hunt, and they immediately deployed antennas to that very part of the sky. But the unknown source of the signal had already disappeared. Scientists have been trying to register this signal again for years. Unfortunately, it didn't bring any results. What is so special about the WOW signal that it has excited everyone for so many years? The fact is that it's almost impossible to explain its earthly origin. This impossibility lies in the most fundamental moment, the frequency at which the signal was received. This frequency is 1,420 megahertz, and terrestrial communications are forbidden to use it. To soften the word forbidden, let's say its use is reserved for the study of extraterrestrial signals. The point is as follows. Let's say we want to pick up a signal from aliens. It was impossible in 1977 to listen to the entire radio range for this. No power would be enough. Physicists Bernard Oliver, Giuseppe Cocconi, and Philip Morrison proposed a rather elegant solution back in 1959, at least an intermediate solution. It comes down to this. By definition, we have no idea about the frequency that hypothetical aliens can transmit something, whether they transmit anything, or even if they exist at all. And if so, then we are free to make any assumptions. Oliver, Cocconi, and Morrison were convinced that 1,420 megahertz was the most suitable frequency for interstellar communication. This is because hydrogen, the most common element in the universe, emits at this frequency. Here, we simplify a lot of things to avoid subtle and obscure details. In fact, there were many reasons put forward for such an assumption that were quite logical and scientific. And then, if we came to this, then why not assume that other intelligent civilizations would make similar assumptions? In any case, we still have no other options than to speculate and reason. The physicist's idea turned out to be quite convincing, and the frequency of 1,420 megahertz was reserved for space research. It's not used by terrestrial means of communication to avoid interference. Now it serves as a hope for those who want to find aliens. It seemed that our hopes would finally come to fruition, but alas. At first, Ayman himself and his colleagues made several attempts to restore and identify the signal. Dr. Ayman's team spent several months trying to pick up a signal at the same area. Nothing. 10 years later, astronomer Robert Gray decided to revisit the issue. In 1987 and 1989, he used the meta-array at the Oak Ridge Observatory. Still nothing. In July 1995, SETI League Executive Director Paul Shook made his contribution to the desperate quest. While testing the signal detection software for the Argus project, he made several observations of the WOW. Shook used a 12-meter radio telescope at the National Radio Astronomy Observatory in Green Bank, West Virginia. But this also didn't bring any result. In 1995 and 1996, Robert Gray also revisited the issue. He went all in and used the Very Large Array, which is much more sensitive than the Big Ear. Astronomers Gray and Simon Ellingson later looked for a repeated event in 1999 using a 26-meter radio telescope at the University of Tasmania's Mount Pleasant Radio Observatory. 6 14-hour sightings were made from nearby positions, but nothing like a WOW signal was ever detected. We aren't just talking about continuous failures of the WOW signal redetection. Each of them consolidated the skeptics' viewpoint. For a long time, skeptics couldn't form a convincing hypothesis explaining the signal's origin. And only in 2017, half a century after the first and last time the signal was detected, such a hypothesis emerged. Antonio Paris, assistant professor of astronomy and astrophysics from St. Petersburg College in Florida, has suggested that the hydrogen clouds surrounding 2 comets, 266P Christensen and 335P Gibbs, could be the WOW source. About 200 studies were conducted from November 27, 2016 to February 24, 2017. They showed that the Christensen comet really makes some noise coming towards the Earth with a similar frequency signal. Almost identical studies were conducted on other known comets, and the results were also similar. Indeed, comets spreading a hydrogen cloud over millions of kilometers around create this kind of effect. It would seem that all hopes have collapsed, and all the magic of the WOW crumbled in the face of boring facts, as always. But many astronomers still reject Paris's theory, also citing quite convincing evidence for its unsoundness. There are indeed many inconsistencies, but no alternatives could be found. There were no new signals, and there was nothing in that part of the sky that could even remotely be considered a potential source of radio signals. This was the case until 2020. Hope was reborn from the ashes when a simple amateur astronomer, Alberto Caballero, published the results of his own research. When studying the area of the sky where the WOW signal was detected, Caballero discovered as many as 15 stars that could hypothetically be the source of the mysterious radio signal. Alberto introduced 2 assumptions. First, he suggested that the radio signal came from an Earth-like exoplanet. This planet, like the Earth, revolves around a sun-like star. The second assumption was derived from the Drake equation. According to it, the planet could be no closer than 500 light-years from the Sun. To compile a list of hypothetical signal sources, the astronomer turned to the Gaia telescope database. The data contained information about the properties and position of the stars in the Milky Way. He selected 66G and K-type stars, which were located in 2 areas in the Sagittarius constellation. Caballero was looking for stars with a radius of 0.83 to 1.15 solar radii. It turned out that only 1 star fits this criteria. The catalog designates this star as 2MASS 1928-1982-264-0123. It lies 1,801 light-years from us. Its characteristics are slightly shocking when considering how perfectly it matches the parameters of our native star. Radius is 0.996 of the Sun's radius. Luminosity is 1.0007 of that of the Sun. The temperature is 5,783 Kelvin. Well, isn't that the twin brother of the Sun? Another 14 Sun-like stars with estimated temperatures between 5,730 and 5,830 Kelvin are also located in the region where the signal came from. However, there's not enough information about their luminosity and radius to conduct the research. but one was enough to revive interest in the topic. Since Alberto Caballero's discovery, there haven't been further breakthroughs in pursuit of the WOW signal source, but the topic itself has gained a second wind. And perhaps thanks to new data, humanity will still be able to catch that very elusive signal. Or some other, it doesn't matter. And when this happens, we are waiting for civilizational scale discoveries